One of the common themes that I've noticed as we've built these labs is that we have some fault tolerance. For example, for our management network, we did NIC teaming. So if one interface fails, the other one can continue to carry management traffic. We put our host in a cluster, and we enable high availability. So if an individual host fails, the VMs can be restarted on another existing host in the cluster. In this nugget, I wanted to walk you through another thing that we can do if we have iSCSI-based storage that can help increase our redundancy. And that is the concept of iSCSI multipath. Now, I drew it down here with two of the VM NICs coming from the iSCSI host connected to the storage network, but it's much more than just setting up two adapters on the same switch and say do NIC teaming, because effectively that's just one path through a NIC team. Currently, we have a VM kernel adapter that's connected via a VM kernel port on switch 2, virtual switch 2 on each of the iSCSI hosts. And the VM kernel port name is storage_A. And in the lab, when we set up the iSCSI, we also assigned a VM NIC to that switch. And then as part of the iSCSI virtual host bus adapter, we bound this VM kernel adapter to the host bus adapter so that it would be used as this iSCSI host goes out and talks to the iSCSI target. So on the iSCSI target, we have LUN0 and LUN1, and we've combined those to create one large iSCSI-based data store. And we repeated the process of adding the VM kernel port and the switch and the uplink for the other two iSCSI hosts as well. So what happens if there's a failure with this VM kernel adapter or switch 2 or the physical switch that we're connected to via our uplink? The answer is we're going to lose connectivity between the host and the storage. And if we have a problem on the network somewhere temporarily, we might have an all paths down type of error that's transient, or we might have a PDL, a permanent device loss, where we can no longer reach the iSCSI target. So to implement iSCSI multipath, to give this iSCSI host multiple paths to get to the iSCSI target, what we can do is create another VM kernel adapter. And then associated with that VM kernel adapter, we give it an IP address. So for the first VM kernel port that we assign for storage, it has the IP address of 10.1.1.101. The next VM kernel that we'll use for iSCSI multipath, we'll use the IP address of 10.1.1, same exact network, logical network, and we'll give it the address of 201. And then as we repeat this for iSCSI 2 and iSCSI 3, we'll use .202 and 203 respectively for the new VM kernel adapter. And then with that new adapter, we can assign that to a new switch. And I believe the next switch number in order is switch number 4. And as part of that switch, we'll associate it with a VM NIC, and we're going to use VM NIC 3, which is available, that the iSCSI host can now use to go ahead and also reach the storage. Now, besides adding this networking, we'd also need to go back to the iSCSI host bus adapter on iSCSI 1. We're also going to bind a second VM kernel port that the iSCSI host can use associated with that iSCSI host bus adapter to go out and reach and talk with the iSCSI storage provider. And that's why it's called multipath, because we can have more than just one path to get from the iSCSI host to the target. So when it's done, here's what we'd see. Instead of having one path to LUN0 and one path to LUN1, we'd have a second path to LUN0. So two paths to LUN0 and two paths to LUN1. Here in the vSphere web client, let's go ahead and click on the Host and Clusters tab if we're not already there, and let's go ahead and start on iSCSI 1 by selecting it. Now, it's often a good idea to verify what we have in place before we start adding additional configuration. So just for grins, to confirm where we're currently at, with iSCSI 1 selected, on the Configure tab and under Networking, we're clicking on Virtual Switches. And let me expand this just a little bit so we can see all the switches. And if memory serves me correctly, we're currently using switch 2 for our access from the iSCSI host over to the iSCSI target. And sure enough, that is the case. So here's switch 2. We have a VM kernel port called storage-A. The VM kernel adapter that's logically connected via this port is VMK1 with the IP address of 10.1.1.101. And then we're using VMNIC 2 as our uplink for connectivity to that storage network. So what we'll do is we'll be creating a switch 4. We'll associate that with a VM kernel port and adapter with the IP address of 10.1.1.201 here on iSCSI 1. And then with the switch, I have in reserve VMNIC 3 that we can use for an uplink for that switch. And then once it's done, we'll bind that to the host bus adapter on iSCSI 1. With iSCSI 1 selected on the Configure tab, under the Networking section with Virtual Switches selected, we're going to go ahead and click here to Add Host Networking. The top option of VM Kernel Network Adapter will let us do virtually everything. It'll let us create a new VM kernel adapter, the port, the switch, the uplink, and everything regarding the basic networking. So with the VM kernel network adapter selected, we'll click on Next. We want a new switch, so we'll click on the radio button for new standard switch, click Next. We'll click on the plus symbol, and then we'll select the only available uplink that we have left, which is VMNIC 3 that connects to the storage network. We'll click on OK, click on Next, and then let's name this storage_B. So that way, when we see this VM kernel port called storage_B, we'll know exactly what it's for. We're not doing any VLAN tagging. We're going to use the default protocol stack. And then because we're using this new VM kernel adapter and its port for iSCSI access, that's not any of these, and we don't need to check any of these boxes. So we'll go ahead and leave them all blank and click on Next. We'll specify the IP address of 10.1.1.201, and then we'll put in a 24-bit mask. We'll accept the rest of the defaults there, click on Next. Here's a confirmation of what's about to happen. We'll click on Finish. And now we have a new vSwitch 4. The VM kernel port is labeled storage_B, and it's associated with the VM kernel adapter, VMK3 at 10.1.1.201, which implies that we have 3 other VM kernel ports. So if we don't remember, which I don't at the moment, we can go ahead and click on VM kernel adapters here in networking, and they're just going to spell it out. So our first VM kernel port is for management, then VMK1 was for storage A, there we go, and VMK2 was for vMotion, and then VMK3 is going to be our second one that we're going to use for storage. Great, mystery solved. So if we click back on virtual switches and also verify here that the VMNIC 3 is the uplink that's going to be supporting this new vSwitch 4. So our next major step is to go to the host bus adapter, the iSCSI host bus adapter, and associate this VM kernel adapter with that iSCSI host bus adapter so it can use it for multipathing. So to do that, still with the iSCSI host selected and on the Configure tab, under Storage, we'll go ahead and click on Storage Adapters. Let's go ahead and bring this down just a little bit so we can see everything. And there under the iSCSI adapter, we have the VMHBA65. So if we click on it and then click on the paths and the adapter details, it shows us that we have one path to each of our LUNs. We have one path to LUN 0 and another path to LUN 1. And it's all using one VM kernel port and one switch and one uplink, and that's why we have one path. To solve that, we'll click on the network port binding and the details of that adapter. Currently, we're using VMK1, which is associated with the port group called storage A and the uplink of VMNIC2. And what we're going to do is we are going to add a second binding by clicking on the plus symbol. So we can click on storage_B and verify the details regarding that VM kernel port and the VM kernel adapter behind it. Select it if that's the one we want, and then go ahead and click OK. It's giving us a message that because we just made some changes, we may want to do a rescan. That's a great idea. So if we scroll down just a little bit, just to confirm that our host bus adapter is still selected, we're going to go ahead and use this icon here to do a rescan. We'll give that a moment to complete. And now for the network binding, it's showing us that we have VMK1 that we had originally and VMK3 that we just added. Also, if we click on paths now, it's now showing us that we have 4 paths, 2 paths to each of the LUNs. And so what we would do is we would repeat virtually identically the same process, except for the fact that when we get to iSCSI2 and iSCSI3, we'd want to use .202 for iSCSI2 and .203 as the VM kernel adapter address on that 10.1.1 network. So what I'm going to do personally right now as part of the lab is I'm going to go ahead and repeat that process for iSCSI2 and iSCSI3, and I'd love you to launch the lab yourself and do it as well. So start with iSCSI1, follow the process that we just went through together, and then simply repeat that process as we add iSCSI multipathing for every single iSCSI host that we have in our data center. So have some fun with the lab, and I'll see you in the next nugget. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.